valence electrons. So you've probably seen some very common things from biology. You saw O2. You've probably heard of this from breathing. So O2 is a molecule. So if you remember when we were doing Avogadro's number for something like oxygen, we would say 1 mole is 6.022 times 10 to the 23rd molecules. So because covalent compounds form molecules as opposed to formula units as in ionic, this is also sometimes called molecular bonding. So that is a synonym for that. Okay, and there are plenty of elements that are diatomic. And these diatomic elements make the shape of a 7 on the periodic table. So nitrogen, oxygen, fluorine, chlorine, bromine, iodine. So there's the shape of your 7. The only one that's a little bit difficult to come up with is hydrogen. But if you remember from your periodic table lab, hydrogen is chemically or physically similar to these. It's over here on this side of the table because it's chemically more like lithium. But that is one way to remember the 7 diatomic elements. So NO, F, Cl, Br, and I. So if you again make your 7, if you're one of those folks that makes that little upper part in the 7, you can get the hydrogen. If you're more auditory in how you learn, you may remember it with this acronym called Brinkelhoff. So again, all the elements: bromine, iodine, nitrogen, chlorine, hydrogen, oxygen, fluorine. That's the one my chemistry teacher taught me. And then the third one is a little bit of both. The elements are genuine diatomics. So the ones that end in gen: hydrogen, oxygen, nitrogen, or the INEs: fluorine, chlorine, bromine, iodine. I guess you could say it iodine, but they changed the pronunciation for that. All end in INE. Astatine would as well, but I don't know any compounds with astatine, so that's a pretty rare element. Okay, so we're going to take a look at this, but I want to just, once people start hearing this diatomic thing, they go from kind of applying it incorrectly. So I'm just going to throw this little piece in here. So oxygen as an element is O2. Chlorine as an element is Cl2. In compounds, they are not diatomic. So if we go back to what you're already familiar with, if I do sodium with oxygen, I get Na2O. So you'll see there's no 2 in the formula. If I do Na with Cl, I get 1 Cl. So not diatomic in compounds. So it's only in their elemental form, and you'll see that elemental form again when we get to chemical equations. Okay, so we're going to start with drawing. The first one I'm going to use is chlorine. Okay, so chlorine, if we draw its electron dot diagram, you're going to see this. So with its 7 valence electrons, 3 pairs and a single. So you might very easily see why chlorine is diatomic. So it's only 1 electron away from having its complete octet. So if I put a second chlorine here, I want these 2 to overlap. So I'm just going to redraw them with the single electron on the side. So atoms are free to move around in 3-dimensional space, and that's why it really doesn't matter which side you start on, as long as you have 3 singles and, or excuse me, 3 pairs and a single. So this leaves me a place where I can actually just very easily insert the other chlorine. So if I'm just turning this one on its side, I'm putting that in. And this pair of electrons is my covalent bond. Okay, so I could also represent that as Cl with a dash. So this is called a single bond. Okay, and I move on to something you've probably heard of: ammonia as a cleaner. Okay, ammonia is the common name of this chemical. So if I do the same thing, I'm going to do my nitrogen. So starting here on the side, I have a pair and 3 singles. Hydrogen is just going to be an X. So when I put those together, and I might decide to put the 2 pairs, or the paired electrons on top. Again, it doesn't matter as long as there's 3. So it's a very easily identified way of seeing how this is completed. What I'd like you to do is to stop the video and complete 1, 2, and 6 on the worksheet. Okay. All right, next compound, or this is actually a molecular element that we're going to do, is going to be oxygen. So oxygen has its 2, so it has a pair and 2 singles. So again, I need another oxygen that basically has the same process to it. Now, this one's a little tougher because we have to get these 2 to pair up. So I tend to do these on an angle, and I'm just going to flip this one upside down, kind of put the 2 pairs here and the 2 singles here. So they've got to be adjacent, and then I'm going to substitute in the X ones here. So if I turn this, I think I'm picking this up and I'm inserting it in here, and that would put my 2 X's out here. So what you see here is there are 2 pairs of bonded electrons. Okay, and this is called a double bond. Okay. All right, I'm going to do one that's a little more complicated. This time I'm going to do, this is called methanol. This is the fuel that's used in Indy cars and Formula 1 cars. So you might remember that carbon is that really important exception. So your book does all of its electron dot diagrams based on what carbon is like because it is such an important exception, but I don't think that's correct to do that, and most other textbooks don't do that. So I have carbon, I have hydrogen, and I have oxygen. So I'm just going to do dots again for oxygen. If you want to do something fancier, that you can, but so the reason that this is not written CH4O is because it's trying to tell you some bonding clues here. So this carbon is going to be attached to 3 hydrogens. So that's why they are written that way. And then this last dot is where I'm going to insert my oxygen. So if I insert oxygen here, okay, maybe I'll put a box over that one so you can see them. That's going to give me an oxygen down here with a little box and the 2 dots here. So these are already full. Sorry, I should have done the box here. So this now has its 8, 2, 4, 6, 8, and then this isn't complete. So it has room for that last hydrogen to put in here. So sometimes we'll see these with just all single bonds drawn this way. Now, they're putting the O in line here, but it's really down this way. Okay. And then lastly, we're going to do N2. So this is the most difficult one to draw. So again, if I start with this, so I'm going to repeat that. So it's easy to see on paper that there's 3 spots open for each. On paper, it's a little more difficult to draw. So I'm going to flip this one, sort of its mirror image here. I'm going to put this one here so the bonding pairs are on the side, and then I'm just going to substitute this one in. So they're kind of far apart. So here's where our paper diagram sort of falls apart, but this would be a triple bond because they share 3 pairs of electrons. So you might remember back when we did gas laws that there's more nitrogen in the atmosphere than anything else. So number 1 is nitrogen with its triple bond, and 2 is oxygen with its double bond. So again, the more bonds you have, the more difficult it is to break them apart. So there's really only 2 things in nature that break this down. One is lightning, so again there's lots of energy there. Sometimes you'll actually smell a weird smell after lightning strikes close by. If nothing's on fire, that's actually probably the smell of some nitrogen compounds that are formed when this breaks and that reacts with oxygen, so you can smell that distinctly. The other is there are nitrogen-fixing bacteria in some plants. This group of plants are called legumes. So soybeans is the most common one in our area. Peanuts, peas are all types of legumes. They have bacteria that live in their roots that are able to split this up, but it's very difficult to break a triple bond. Okay, everything else that's in air are all trace. Okay, and they all are things that tend to be singly bonded. So the more bonds you have, the more strength you have. So those are things like carbon dioxide, water. I shouldn't say carbon dioxide. Let me get that one out of there. There is carbon dioxide as a trace, but so water, a little bit of helium, a little bit of hydrogen, those types of things, pollutants, all of that are just smaller amounts of what's in our air. Okay, all right, you should be able to complete the rest of the diagrams on your paper and submit that.